Back with another study club video here with Arvan. I'll be teaching you guys just the general knowledge about bonding, chemical bonding, ionic covalent as well as metallic bonding. We'll be using this will be really helpful throughout GCSE as well as IB, as it's always relevant some way or another in our papers as well as our exams. Starting off with ionic bonding. Ionic bondings are between metals and non-metals. And the main idea here is stealing or giving and taking. For example, here we have a electron structure of the sodium, and we could see that the valence electron here is 1. And usually below three, yeah, they give out electrons, and above 3 or above 4, they take in electrons. So the main goal here is to be stable or to be octed. And here sodium is giving out 1 in order to be octed, and so its second shell would be octed, 8. And giving out 1, and Cl will be receiving 1, which will make it octed and make it stable. And when an atom gives out an electron, it will make it into an ion, which will make it into positive. When it gives out, it becomes positive, and when it takes in, it becomes negative. So it's shown here, Na plus and Cl minus. Here's another example, magnesium and oxygen. We could see that magnesium has 2 valence electrons, and below 3 we would always give. So magnesium would give out 2 electrons in order to be stable and octed. And oxygen would have to receive 2 because it has 2, 4, 6 only, so it requires 2 more to become octet and stable. So whenever an atom gives out, it will become positive, and whenever an atom takes in, it becomes negative. So usually in our papers, when they ask us to draw a ionic bonding between these elements, we usually answer like this to show it clearly. So we draw the electron structure of magnesium when it's stable, and we provide it with how many electron it gives or it takes. And due to the charges being equal and opposite, they tend to form large crystalline structures, which is one of the properties of ionic compounds. Ionic compounds also have high melting point as well as boiling point, and they would be usually soluble in water. For example, salt, as we all know, it will be soluble in water, and once it dissolves or in molten form, it will be able to conduct electricity. Otherwise, in its solid form, it cannot conduct electricity well. Moving on to covalent bonding. Covalent bonding, we can see that the difference between covalent and ionic, that covalent is between non-metals, so it's non-metals and non-metals. And here the key feature is it shares electrons. So here is an example between hydrogen and hydrogen. They're both nonmetals, and they need to share 1 each in order to have both of the shells stable, because the first shell is always 2. For example, first shell is always 2, second shell is 8, next is 16, and so on. That's how you usually draw a electron diagram. So for a hydrogen to be stable, it needs 2 electrons in its shell, so they would be sharing 1 each to make both stable. Another example is oxygen and hydrogen. Oxygen has 6 in its valence electrons, and it has 6 valence electron, and it requires 2 in order to be octet and stable, as well as hydrogen requires 1 to be stable as well. That's why OH2 2 hydrogen is required for an oxygen to be stable, and here we could see that each hydrogen shares 1 and oxygen shares 1 to each hydrogen, which makes the compound stable, which makes each element stable with its full outer shell. Here's another example of carbon and hydrogen. It's clearly labeled here, the electron from hydrogen and carbon, and we could see how it shares 1 each in order to make each other stable. And usually in IGCSE papers, they usually ask like how many electrons are in a covalent bond. And a covalent bond, a single covalent bond is like hydrogen and carbon here. You can see that in one covalent bond here, there's 2. There's 2 sharing electrons. So usually, if it asks for that, you just count the electrons that are being shared. Might be tricky, and due to the shared electrons and its structure, a covalent bond would provide a low melting point as well as boiling point, and it will be a bad conductor. Moving on, metallic bondings, it's just between metals, so metals and metals. Here's an example of zinc ions and sodium ions. So these are positively charged atomic nuclei, and the small negative circles are delocalized electrons. These delocalized electrons do not belong to any of the ions or the atoms. Therefore, they are free-flowing electrons, which allows them to travel freely, which also helps with its properties, which is being a good conductor in heat and electricity, as well as having high melting point and boiling point. So metallic bondings are just so, pretty much straightforward. A summary of this whole presentation is ionic compounds or ionic bonding is for group 7 atoms steals from group 1 atom, and high melting point. It would have high melting point and high boiling point. Soluble in water, conducts once it's dissolved or molten, and it forms crystalline structures. Covalent bondings are nonmetals and they share electrons. Remember, they share, and ionic gives and takes. And covalent would have low melting point and boiling point, and it would be a bad conductor. For example, plastic. Plastic is a type of covalent compound, and we know that it is low melting point, has a low melting point and a low boiling point, and it's a really bad conductor. And a metallic bonding, they have a delocalized cloud of electrons. That's one of the key terms to metallic bonding, and they are good conductors of electricity and heat, and they would have high melting point as well as boiling point. That is all for the bonding. That is all for the chemical bonding for ionic, covalent, and metallic. Thank you.